Okay, hopefully we're live. So good morning everybody. We'll have a quiz on Friday, April 2nd. April 2nd. So here's the review, and I hope you do it. So first of all, right off the bat, number one, it says graph 3/2 x minus 4 and its inverse. So let's get out a piece of graph paper. I'm going to do this. If I get going too fast, you can always pause the video and catch up. So number one, I'm going to graph this. I'm going to get my XY axis down. I'll do this one in blue, and then I'll do the inverse in red. So if I start at -4, I'll have in blue 1, 2, 3, 4, right? And with a slope of up 3 over 2, up 1, 2, 3 over 2. Here is f of x. This is my original f of x. Now, if I want the inverse, okay, one of the ways we can do it is we can just take our points and switch our points, right? So we have a point at 0, -4. We've got a point at 2, -1. We got a point at 1, 2, 3, 4, 2. If we switch those points, we'd have a point at 0, -4, 0, which is 1, 2, 3, 4. We'd have a point at -4, 0, right? We switch the points. -1, 2. We have a point at -1, 2. We'd have a point at 2, 4. 1, 2, 3, 4. And there's my inverse graph. Okay, so just switch the points and graph it. Now, what's the equation? Well, the easiest way to get the equation is switch everything. So instead of y equals 3/2 x minus 4, let's switch it over to an x. Remember, switch the variables. X equals 3/2 y minus 4, and I'm going to solve. So plus 4 plus 4, x plus 4 equals 3/2 y. I'm going to multiply by 2, and I'm going to get a 2x plus 8 equals 3y. I'm going to divide by 3, and I'll get a 2/3 x plus 8/3 equals, and that's my inverse, so f inverse of x. Okay, so that's the answer to the inverse equation. I'm going to circle that. So I've got the graph, and I have the inverse equation. There it is. Okay, all right. Number two, simplify. Well, these are pretty easy because it's just like dealing with exponents. I'm going to have an e, add exponents, e to the -2, which is fine, or if you want to get fancy, 1 over e squared. I'll take either answer. Okay. B, I'm going to reduce the whole numbers. 6 24ths makes a 1/4. 5 of these e's, cancel 5 of these e's, and I'm left with an e to the 3rd. Okay. Number 3, cube root is like taking a 1/3 power. Before I do that, though, the cube root is 64. Let's see. 4 times 4 times 4. 4 times 4 times 4 is 6. The cube root of 64 is 4, and I'm going to take a third of the exponent, so I get an e to the 6. Okay, so here's my answers for A, B, and C. Again, if I get going too fast, just pause the video. Okay, number 3. So to graph this, and we're not going to use our phones. We have to use a calculator, and you can borrow my calculator, but I'm just going to go to y equals. We've done these before. I keep trying to teach you guys these so you can do this. Okay, so if I go 12, and I go my e to the 0.3x. Let's see what it looks like. Okay, should be going like that. Okay, and if I go ahead, and I'm going to fix my window a little bit. I'm probably going to have to go up a little bit higher than that. Let's go to 24. Let's graph that. Okay, there it is. All right, so it grows by 30%. So if I go ahead and put my graph for number 2 down, I'm going to have to go up to, if it was negative, it would be going down. If the exponent was negative, it will be going down. So I'm going to start at 12. I know that. And a few features I need, let's go by 2. 2, 4, 6, 8, 10, 12. Okay. I need the shape. I need the correct y-intercept. It goes like this. Okay, I need the right shape. And I need my asymptote, which is at 0. Okay. That's what I need. Now, is it growth or decay? Obviously, it's going up, so it is growth. The domain, well, that's easy. How wide is it? The domain is all real numbers. but the range, it will never touch. It'll never touch 0. So the range is y is greater than 0. Okay, moving on. That's not too bad. Number 4, rewrite as a logarithm. Okay, so I know I've got these rules. If I have my base to an exponent equals an answer, I hope these are in your notes somewhere. I can rewrite that as log of some base of my answer equals my exponent. So I'm going to rewrite this. So this one to write as a log. I'm going to go log. That's my base. That's my base. Base 7 of my answer, moving it from here to here, of 49 equals x. Boom. That's it. And we've done this. You guys are getting good at this, okay? B, I'm going to go log base e of 25 equals x. But I would like you to write this, log base e is natural log. I really would like you to write that. I'm going to rewrite this as natural log of 25 equals x. Okay? I'm hoping you guys will write that. Log base e is natural log. Okay, 5. We're going to rewrite this from log form to exponential form. Okay, so we're going to take it from here to here. So I'm going to rewrite this as, you ready? 4. That's my base. My base is 4. 4 to the x power equals 32. Done. So all you got to do is just rewrite it. You don't need to solve it, just rewrite it, okay? B, it has an invisible base. Invisible base is e, right? Because it's natural log. So we're going to go e to the 12th power equals x, okay? And that's it, okay? E to the 12th power equals x. Done. Exponential form, okay? C, there is an invisible base. Since it's regular log, it's base 10, okay? Regular base 10, so we're going to go 10, because that's my base, to the x power equals 25. So we're going to go 10 to the x power equals 25. Boom. Done. Okay? Now, evaluate. So there's 2 ways to do it. You can evaluate by your calculator if you have a fancy calculator, or I can just go ahead and go 2 to the x power equals 64. And I know that 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32 times 2 is 64. I know the answer's got to be 6, but if you can't do it, you can always use a calculator. There's 2 ways you can do it. We've learned this before. If you don't have a fancy calculator, you can go log of 64 divided by log of 2. We've learned this before. It's one of our log rules. Okay, and you get 6. Or if you want to use one of my fancy calculators, which you're welcome to, I go to math, log base 2 of 64, and sure enough you get the same answer. Okay, either way you get 6. Okay. B, I'm going to change to a logarithm. Okay, I'm going to because you can't do it in this form, so we're going to rewrite this as log base 10 of 80. And log base 10 is your common log. It's regular old log in your calculator. It's going to be like just a log of just plain old log of 80 because it's common log. And I have that in my calculator also. Just plain old log. So I go log of 80 and I get my answer. It's about 1.9, which that makes sense. We knew it was close to 2. So x is about 1.9. Okay. C, you're going to need to remember what the magic invisible base is. So the invisible base with natural log is e. Got to have it e. Got to have the e there. And we're going to change this to exponential form. We're going to go e, that's my base, e to the 1.4 equals x. So e to the 1.4 power equals x. And that's an okay answer. Or if you want to just go ahead and use your e button to 1.4, we get about 4.05, 4.06 maybe, if I round it. Okay? Or this answer's too. I like either one. I like this answer because it's nice, or that answer. D. So if I change it to a logarithm, it's really going to help. So I'm going to go log base 8 of 533. Okay, so there's 2 ways to do it. Okay, one, I taught you I can go log of 533. I can just do change of base, log 533 divided by a log of 8. That's one way to do this answer. Okay, change of base. Or you can find the fancy math button. I like the fancy math button. Log base 8 of 533. same answer. About 3.02 maybe. Okay, there you go. All right. Hopefully you guys are following along. Okay, on the back side, we're almost done. Rewrite this log equation in expanded form. Let's see what we have. We have imaginary times sign right here and a divide sign right here. Okay, so we're going to rewrite it, and when I see the times, I separate them with plus signs. And with the divide, I'll separate with a subtraction sign. We've learned this. So I'm going to go log base 3 of x squared plus because of the times sign, log base 3 of y, and then subtract, because I got a divide by sign, subtract log base 3 of z. Okay, now there's one more thing I need to do, and I'm going to bring my exponent down. I'm going to float my exponent down, and I'm going to rewrite this as 2 log base 3 of x plus log base 3 of y minus log base 3 of z. So it's completely expanded, which means, you know, believe it or not, it's 3 very simple log problems. That's what we want to do. Okay, number 8, we're going to do the opposite. Okay, we're going to do the opposite. So first of all, let's bring our exponents in. These were exponents that got floated down. Okay, so let's bring them back in as exponents. This was an exponent that got floated down. Let's bring it back in. Okay, this is an exponent that got floated down. Let's bring it back in. Okay, so I'm going to rewrite this first as log of a to the 1/3 power, right? Because I bring the exponent back in, plus log b to the 6th power, because I brought the exponent back in, minus log c and squared, because I brought back in the exponent. Now, if it says plus, I'm going to multiply. If it says subtract, I'm going to divide. Single log, we're going to go log of a to the 1/3 power, which is really the same thing as the cube root of a, times, I don't need the time sign, but there it is, b to the 6th, and then divided by c squared. There it is. Okay, wrote as a single log. And finally, number 9. Okay, bacteria grows exponentially, continuously. Ooh, that means we're going to have to use the number e, aren't we? We're going to have to use the number e because it's continuously at a rate of 3% per hour. So I'm going to know my rate's 3%. Initial population, well, that's my beginning amount. That's got to be 500. How many would be there in one day? Well, one day means that I'm probably going to let my t equal 24. One day, 24 hours, right? So let's see. The equation we learned in class was this. A of t, amount over time, is equal to our beginning population, that's 500, times e to the rt. R is my rate, 3%, and t is my time. So we've got to have this formula in my notes somewhere. Okay, make sure you have this formula in your notes somewhere to do this problem. Okay, there it is. Now, let's do it. So I'm going to go A of t equals 500 e. Now I'm going to change this to point, right? 0.03, because that's how I change a percentage into a decimal. 0.03. And my time is 24 hours times 24. Now I'm going to need a calculator. Okay, so I get out my 500. And I'm going to use my E button to the 0.03 times 24, and I get about 1,027. And that's in terms of bacteria cells. Bacteria. Okay, so quiz on Friday. Make sure that you do the review. It will really help you a lot.